Welcome back. Yesterday we talked about getting the slope and y-intercept from a graph, and today we're going to talk about getting the slope and y-intercept from a table. Okay, so we're deriving the slope and y-intercept from a table. So say that we have this given value of this given table, and we want to find the slope. Now remember, the slope is, if we know it's a line, then it's pretty easy to find the slope. It's just going to be the ratio of the we're just going to use the slope equation. That's what I'm trying to say. So y2 minus y1 over x2 minus x1. Okay, so what we have to do is pick a point 1 and a point 2. Let's just pick these two right here. So let's say that this is point 2 and point 1. So our y2 is going to be, this is our y2. Let's just label them as, it's a good habit to get into. Whoops, see, I already made a mistake. This should be x2. This is x1 and y1, okay? So now it's just easier for me to put the numbers into the formula because I've already labeled them. Okay, so here's that, and that's divided by 4. So our slope is going to be 5 here. So our m is equal to 5, right? Now to find the initial value or the y-intercept, there's two methods. We can either see if we can work backwards in the table, or we can derive it from the formula. So working backwards in the table is, well, I'm wondering, and actually it's kind of easy with this table because it's going by twos. So one way you could do it is say, well, okay, well, what is x? Because remember, we're looking at the y value when the x value is 0. So here it's as if I'm trying to make, let me make the, put a little a column in here. If the x were 0, what would the y be? So it looks like if these are going down by 2's every time, then going from 2 to 0 is also the same, it's the same decrease. So what I can do is, since the x's are all decreasing by the same amount, this is going subtracting by 2, then I can pattern the decrease of the y's in the same way. So this is going down by 10, right? So this is going down by 10. Well, negative 22 minus 10 is 12, or 22 minus 10 is 12. So when x is 0, y is 12. So the y-intercept, or the initial value, is going to be 12 because the coordinate is 0, 12. All right, so the b here is 12. Okay, the other way you can do it, if it's not possible to work backwards, meaning if the increases are sort of variable, let's say that it went down by 1 or went down by like 20 for the x values and you have to only go down by 2, it might be a little bit more difficult to work backwards in the table. So the other way you could do it is, well, what you know is you know the slope, and you can pick a point here. So you can pick any point, it doesn't matter which point. Let's pick 222 because it's a small point. Let's, so we're working with a point. So here is, step 1 is to pick a point. And step 2 is substitute values in. Okay, so we have 222. Now, we also know that the slope is always equal to 5 regardless of what point I put in. So basically, we have everything that we need in this equation except b. So let's substitute this point in. So it would be, this is our x and y coordinate. So we'd have, for y, we'd have 22 is equal to, our slope is 5 times 2 plus b. So essentially, remember, the reason why we can do this is because this point is a solution of, it's a solution because it's in the solution table. Well, what it means to be a solution is that it's a point on the line, which means that I can substitute it into the y equals mx plus b formula and derive b from this equation because I know it's a solution. So we have 22 is equal to 10 plus b. Let's subtract 10 from both sides, and I would get b is equal to 12. So I have my m and my b. So all I'm doing here is rewriting. All I need here is the m and the b. That's all I need for this equation. All right. At this point, I can sort of disregard my my use of this point. I don't need this point anymore. It has served my purpose. I've already found my b, so I can just rewrite the equation as 5x plus 12. Okay, and that's the equation for the work inside the table. So if you'll notice, anytime, so like let's take this point right here. 5 times 6 is 32, 32 plus 12 is 42. 5 times 8 is 40, plus 12 is 52. So every single point in your table abides by the rule that when you take x, multiply it by 5 and add 12, you get y. Okay, let's do the same thing for another table. Let's get some more practice here. If you wanted to, you could stop the video and see if you can do this yourself and then come back and check your answer. So finding the slope is easy. Just pick a couple points here. Let's pick this as 0.2 and 0.1. So P2, P1. That makes this x2 and y2 and x1 and y1. Okay, so my slope formula is y2 minus y1 over x2 minus x1, which is 29 minus 22 over 4 minus 3. That's a 3 there. Oops. So it's 7 over 1, which is 7. So my slope is equal to 7. Okay, it looks like, again, that I can work backwards pretty effectively in this table. These are all decreasing by 1, right? So when the x decreases by 1, the y decreases by 7. So it's subtracting 7 here. You can also see that in terms of the slope. So the slope says that for every 7 increase, if I were working backwards in the table here, or working forwards in the table rather, it would say that every time y increased by 7, x increases by 1, right? That's what the slope says because it's 7 over 1. That's another way of looking at it. So all I have to do to figure out, let's put another cell here, all I have to do is that when x is 0, we do 8 minus 7, which is 1. Okay, so our b here is 1. Likewise, if I put, so right here I can actually already write my equation, but let's just pretend that I need to use method 2 so that we get some practice with that too. So we'd say, pick out a point. Let's pick out 1, 8. I like picking out the small points, and that way it's easier to multiply out. So if I pick out a point, I carry from the step 1, I carry the slope, and I put everything into the equation. 8 is equal to 7 times 1 plus b. Well, 8 is equal to 7 plus b. Subtract 7 from both sides. So we'd have b is equal to 1, which is exactly what I got here. So this is our equation. All right. Okay, now let's work with a word problem and see if we can find the slope and y-intercept from a word problem. So a phone salesman is paid a minimum weekly salary and a commission. We talked about what a commission was, right? That's a price per every item that he sells. So he gets a certain amount for every phone that he sells. And the number of phones versus his weekly income is shown in the table below. So we are to confirm that the relationship is linear and give the constant rate of change and the initial value, okay? So to confirm that it's linear, we have to make sure that the rate of change is constant. So let's do this. So every x value goes up by 10. So since the rate of change for the x is constant, we would assume that the rate of change for the y is also constant. And it is because everything goes up by 150. Okay, so to find the slope with that information, we would take, we actually have already figured out what the, well, let's do it this way. M is equal to y2 minus y1 over x2 minus x1. Let's pick a 0.1 and a 0.2, okay? Let's think about maybe these being 0.1 and this being 0.2. Doesn't really matter which one, right? This is going to be y2, this is x2 and y2, x1 and y1. So x2 is 780 minus 480 over 30 minus 10, which is going to be 300 over 20. Now how many 20s are there in 300? Well, there's 5 20s in 100, and 5 times 3 is 15. So that's going to be 15. M is equal to 15. Now, again, if we wanted to work backwards, which is pretty easy here because everything's decreasing by 10. So 10 minus 10 is 0. And then if we take 150, 480 minus 150 here would be 330, sorry. So it's going to be 330, and that is going to be the y-intercept here. So 330. So we have our equation here, y equals 15x plus 330. So from here we can actually pick out the his minimum weekly salary, right? His minimum weekly salary is the initial value. Before he sells any phones, he gets $330, right? And then his commission for each phone, we can pick out from the slope here, because the number of phones sold is the X. So that means the commission is $15 per every phone. So you take the number of phones he sold and multiply it by 15 in order to get his commission. All right, so here we can just pick up an answer. If we were ever asked to answer, well, what is his weekly salary and what is his commission, we can pick them out from the Y-intercept and the slope respectively. Now again, we could use the second formula in order to find the second method in order to derive the Y-intercept if we would like to. So we could just pick a point. Let's pick 10, 480. And then let's take y is equal to 15 times the x value, which is 10, plus 480, and that's equal to, well, actually, sorry, the 480 is going to be the y, and we would be, in this situation, looking for the b if we hadn't found it already by working backwards. So 480 is equal to 150 plus b, and again, if we subtract 150, we're going to get the 330 that we got. Okay, so just two different ways of doing it. And from here, I would have taken the y-intercept, which is the same as what we got here, and the slope, and put it into this formula. Okay, and that's the end of the lesson for today.